Okay. So our talk is about discussions about principal bundles, and so let's continue discussing them. So basically, we saw the construction, how from vector bundle we get principal bundle. And actually, you can go the other way, and the corresponding construction is called associated vector bundle. I don't know how to say. Okay, so construction is like that. Let me fix some principal bundle. So principal bundle over X. So it's G principal G bundle. Right. And so, well, then I also need to fix representation of G. So G is a Lie group, and I fix representation of G. So representation is such a pair. So this finite dimensional vector space, this is homomorphism from Lie group homomorphism from G to GLV. And Lie group homomorphism means that it's smooth and group homomorphism. Right. So once I fix this, by the way, I'm kind of now in doubt if I need to write principal like this or like this. What do you think? I need to check. So it might be. So it's in Russian it's on главный, главное рассвоение, а не принципиальное. Так что может быть скорее второй вариант. Okay. So let's see. Yes, and so we want to define associated vector bundle. So we define first the following manifold. So we denote it like this: P times V over rho. So this is P is just direct product over some equivalence relation, and equivalence relation is given by the following: P1 V1 is equivalent to P2 V2 if and only if the following happens: P1 V1 P1 V1 equals to P2, and then action by G inverse for some G, and then rho of G action on V2. So like that. So basically you have some pairing which is invariant with respect to action on fiber and on V. So on fiber we have action from the right and V from the left, and so therefore it's a well-defined construction. So anyways, that is what we have, this equivalence relation, and we define such manifold. Now I would like to see that this is actually vector bundle over X. So I need the projection. Let's call it PV, pi v. So this is from here to X. This projection goes like this. So I send, well, it's just very natural. I take equivalence class with representative given by such pair and send it to pi of rho. So I just ignore the second entry and apply pi to rho. Sorry, this should be like p. So rho is representation, this is p. Like this. Right. So this is well defined because for different pairs, these p's they are in the same fiber. Right. And okay, so I have projection, and I would like to see that this thing is vector bundle over X with actually fiber V. So I need trivializations. So let me take U, which is trivializing neighborhood of our principal bundle P, right? So therefore I have diffeomorphism psi from pi inverse of U to this, right? U times G. Okay, then I would like to define psi V. So write it here. So this will be trivialization for this vector bundle. So I need to send, well, I will need to send pi inverse of U to U times V. And I would like it to be diffeo. And so this is defined as follows. So I take, so pi inverse of U, well, I should have to put V in here. All right, so this should be an element in here. So this is just some, again, class with a representative given by such pair. And I send it to pi of P, and in V, the corresponding component of V will be P2 psi of P V. Well, action on V. So again, what let us unveil what is going on here. So what is P2, first of all? P2 is projection from U times G to the second component. Right, so I take psi of P. So I take psi of P. This gives me a pair U and G. Then I project it to G, get an element of group. And then I act by this element. So I guess I need to take this brackets and this. So like this. Right, so I take by psi, I go from here to here. By P2, I go from here to G. I get an element in G, and I act by this element on V. So that's what's written here.
правой доске U это окрестность уже в X, а не в P.
Да.
То есть,
Ну, значит, это будет, ну, так и должно быть.
ну, да, так должно просто...
Но она изначально тоже была в X, потому что это тривиализующая для P, которая тоже над X находится. То есть у нас было, значит, главное расслоение над X, мы получаем векторное над X же. Вот. Значит. Okay. Well, we need to check that it is well defined, right? So I can take something else from equivalence class, right? So psi v is well defined. So I take something the same class, but different representative of this class. So I act by some G on G inverse from the right, and G act by G on V. So I consider such a pair. This should give me the same result under the map psi V. Right. So this will be pi of PG inverse, right? So I'm just using the definition, and P2, right, of psi PG inverse applied to V. Right, so this is the same as P of pi of P, right? Because action of G only moves us inside the fiber, right? So this is the same. Now this guy, so I claim that this is just yes, and G. So I need to put also G in here, GV. So action on G, right? Because I put here G. Right. So just from the definition of trivializing map, it commutes with action, with the right action on here and right action in here. That's just the definition of principal bundle. So therefore, this G inverse goes outside. And we have all this stuff, P2 composed with psi of P, but then I have this acted on by G inverse, and then this guy acts on GV. I need to. Right, so this G inverse and G, well, because it's an action, I can just multiply them and get identity. So this, I can just, cancel them, and I will get the same as here. So it is well defined. And I would like it to be, well, it is smooth because, I don't know, we have Lie smooth action and Lie group. So basically everything involved here is smooth. We need inverse which is smooth, right? Well, I'll just present the inverse for you. So inverse is given by this. So I take pair that lives in here and go this direction. Then I will get psi inverse of x e g. So psi inverse, which is this psi. This is one component, the other component is just V itself. And so this is equivalence class corresponding to such a pair. So this is identity in the group G. And you can check that this is actually the inverse. So if you compose it in either directions, this will give you identity.
Ну, то есть было главное же расстояние, и теперь получили рисуем V уже другие.
Да, да. Векторное рисование с слоем V.
Ну, а что с вами произошло? То есть как бы, был слой G, стал слой V, то есть... Сейчас.
Ну, собственно, все.
Ну, вот эта подкрутка еще есть. То есть это на ро. Ну, вот.
Ну, эта подкрутка на ро нам нужна была, чтобы, значит, ну да. Она и есть, но эта подкрутка нужна. Мы как бы так избавились, грубо говоря, от, ну, от этого действия от G. Ну, я не знаю, она действительно нужна, чтобы вот просто для конструкции, вот и все. Вот. Значит, ну как...
Ну, казалось бы, вот если просто как бы без обычно просто умножать, то как бы будет слой G умножить на V. То есть было P со слоем G, как бы умножили на V, получили слой G умножить. А здесь просто V слой.
Ну как, вы просто заменили, грубо говоря, слой, а если бы просто бы умножили,
да, просто.
вы бы еще один, как бы, вы еще одно бы измерение добавили. Вы как бы не заменили бы один слой на другой, вот, а вы бы еще добавили, это как бы дополнительная степень свободы такая бы была бы. А здесь, так как вы как бы сказали, что действие туда и сюда одно и то же, то вы как бы реально один слой другим заменили. Вот все. Okay. So how you can sell this construction? One way is that actually, if you have vector bundle E, so suppose you have vector bundle. Then actually we say that you have a bunch of other vector bundles, right? I don't know, E tensor K, I don't know, lambda K E, SKE, and I don't know, E star. So these are all packed inside principal bundle PGLE because they are all associated vector bundles to PGLE for different representations. So all are associated vector bundles of PGLE. Well, I don't know, E itself as well, right? So for E you take just you have GLN C, right, and you have action acts on Cn. Well, I don't know why C, just whatever field you take. Let's just talk about R. Right, so it acts on Rn, and so if you start with real vector bundle, right, and you consider PGLE, construct associated vector bundle with such an action, which is the same as representation, and you get E. You can, then you can take tensor power of this V. Okay, if you get this, you can take, you can consider any anti-symmetrization actually, right? You can take any, I don't know, if you know, you can take any Young symmetrizer corresponding to any partition lambda, and this will give you some representation V lambda of GLN, and actually you can form something which is you can denote like S lambda E. You know, you have a bunch of vector bundles just from studying this guy and representations of GLN. But also this is something that is very handy when you talk about some general stuff, associated vector bundles. Okay, so this is one thing. Another thing that I wanted. So next, let's introduce what's principal connection. Okay, so principal connection. Okay, let me switch to this. I think this is more natural. So okay, let me consider principal G bundle. Sometimes people just say G bundle. And it comes together with right action. So P times G to P. So this is right action. That we have on this right G action, right? So of G on P. And what I need, I'm just fixing notation. I need a map that I will call alpha G. This is for any element G from G, and this is from P to P. And this is just restricting this to one point in G, right? So alpha G of P is the same as alpha of PG.
То есть этот же бандл слева как бы в слое действует?
В слое.
Слева действует.
Нет, в слое справа. На правое действие. На слой в главном расслоении.
Ну это и есть оно.
Это и есть оно, да. Yeah, мне просто, I just need this notation for what comes next. Well, and what comes next is actually just a generalization of linear connection, right? So this is fiber bundle, of course, like some particular case of fiber bundle. So I can consider Ehresmann connection. So connection HP on P is called principal. If the following thing happen. Well, so to say horizontal bundle is invariant with respect to this alpha G. Namely, if I consider the horizontal, the fiber of horizontal bundle at point P dot G, so this element of G acts on P from the right. This is some element from P. So this should be the image of HP of P under this map well, I need to take differential of it at point P and apply.
Что такое HB?
Это наш выбранный под рассвоение в ТП, в касательном рассвоении к P. Вот. Ну, выбранное там такое, ну, значит, это связанность. А связанность это то же самое, что выбор горизонтального под рассвоение в ТП. Ну, здесь у нас есть канонически заданное вертикальное. Не, ну как, да, это с прошлых, значит, родов. У нас есть канонически заданное вертикальное под рассвоение на P. Вот. А горизонтальное, дополнительно к нему, вы можете выбрать. Вот. И вы можете как бы дифференциал сечений вы можете проектировать на вертикальное направление вдоль горизонтального выбранного. И это и будет ковариантная производная.
Ну это все таки горизонтально. Горизонтально проектируется.
Не, проектируется на вертикальное как раз. И это, да. То есть если у меня, значит, мое сечение выдает, оно как бы выдает вектора, которые находятся в HP, вот, то от него, оно как бы плоское. От него ковариантная производная просто 0 тогда будет. Значит, ну хорошо. We had a similar definition for linear, right? For linear, this map was just a multiplication by scalar fiber-wise, right? And we had some similar thing. Okay. So we need another description of principal connection, which is like equivalent definition. For that, I will need to recall what is a Lie algebra. We don't need too much out of it. So just if I have Lie group, then I can consider the corresponding to this Lie group Lie algebra. And usually it's denoted by Gothic small letter G. It is a vector space. Mostly we will just need from it that it is a vector space which is equal to a tangent space of G at identity. And well, this is algebra because it has additional structure which is called Lie bracket, but we will not even need this. Hopefully, if I remember correctly. Okay, so, all right. Now let me introduce the following notation. So suppose I fix an element xi in G, then I will write gamma xi of T. So this is curve in G such that, well, first of all, at 0 it is takes value identity in G, and its tangent vector at 0 is exactly xi. Well, there are a bunch of such curves, of course. There's a good choice which is called which is just matrix exponential, right? But in what follows, I will any such curve would work. Okay. So once I have this, I know that actually my VP. This is vertical tangent bundle of P. It is actually trivial. It is trivial with fiber in G. And well, this is because I can give you map as a morphism that it's better to define it this way. So I take a pair, point P, and an element in Lie algebra. And then I consider the following. So then I will have curve gamma psi. So this is a curve in G. It can act, so each element of this curve acts from the right on elements on P, right? So this now becomes curve in P. I can take its derivative at 0, and this gives me tangent vector to TP, which is of course in vertical direction because my Lie group acts just like it just moves things in fiber, right? So if I take differential of this action, d alpha, right, this just gives me vertical direction. So this is a trivialization of vertical bundle, and we just say that vertical bundle is a trivial bundle with actually fiber G, and this is how this identification goes. Okay, so now
То есть это все следует из того, что у нас связано с принципом вакуума.
Значит, ну да, вообще нужно использовать, да, то, что у нас там принцип.
Ну да, то, что мы горизонтально, прямой горизонтально.
Да, да. Ну как? Нет, вообще, сейчас, дайте-ка я подумаю. Не, мне кажется, что это... Не-не-не, это вообще не зависит никак от выбора HE. ВП — это канонически выбранный. И смотрите, у вас как бы... Ну, давайте я картинку нарисую. Нет, мне кажется, что это вообще не зависит никак от HP. Значит, у вас есть ну, ваша база, да, есть вот этот P, и есть слой над каждой точкой, ну, который на самом деле и есть G. И вы говорите, что ВП — это как раз вектора, которые как бы вдоль слоя расположены. Ну вот, и вы говорите, что ну окей, давайте мы возьмем тривиализацию такую, что, ну, грубо говоря, единичка в G соответствует вот этой точке, но тогда соответствующие вектора мне просто будут соответствовать как бы касательно векторам к G в единичке. Вот. А это как раз есть элементы алгебры Lie G. Все, больше ничего не сказано. Окей.
ВП значит вертикально.
Да. Вертикально то, что схлопывается при проекции. Это ядро dp. Значит, да, да. Ну, потому что это более-менее то же самое, что касательное пространство к группе. Что? Слой, ну, практически группа. Ну, как бы группа там транзитивно действует. То есть вы должны, как бы, если вы выберете точку, то да, там у вас задаст какой-то дифеоморфизм. То есть это не, ну, как бы, у вас нет канонического, у вас есть какой-то. Вот. Okay, so now we would like to consider connection one form. So this is just a projection to vertical along horizontal, like which is just seen as a section of T star P tensor VP. So it's one form because it depends on a vector, right? So it takes vector in TP and gives me projection, gives me some value in here. Okay. Then, since I have this isomorphism, I get some form omega, which is, well, this is a form in gamma of T star P tensor P times G. Well, if I have isomorphism of, so this is actually gamma of this tensor gamma of this. The gamma of this is isomorphic to gamma of P times G. And then I, so I get, so this is isomorphic to this and corresponding image. Okay, let me define by different letter for some reason. Well, because I would like to stress that this takes value in G. So that's what they, like if you look up in some sources, right, they say that principal connection is one form on P and is a Lie algebra valued one form in P. So that's what it is. Okay, and also we would like to introduce notation for this guy. So let's denote this. Well, so we just denote. So let me write it separately there. So I would like, so if I have psi, an element in G, I would like to consider psi, what I will denote psi bar, which is vector field on P. And its value at point P is exactly what's written over there. So I take gamma psi acts from the right on P and take tangent vector to this. Right. And so by construction, I claim that omega of psi bar, so this is in vector, so if my omega is this psi bar, then I will just get, so then I get an element in here, right, which is, if I put this into point P, right, I will get element in G. So this will be just Xi. This just follows from construction. Right, what do I get? I take vector Xi bar of P, which is already in vertical direction. I project it to vertical direction, and then use this identification, but backwards, and so I get Xi. This is just tautology coming from, you know, general construction. Okay, so I have this Xi bar, and so my omega of Xi bar gives me Xi at point P. Well, basically, and this doesn't depend on the point actually. This for any P. All right, so proposition. Okay, now I need to define a joint action. Why I need this is because I would like to have some definition of principal connection saying, okay, this is G-valued one form on P, satisfying two things. So this will be one of this thing. And the other one is now the proposition that we are going to formulate right now, but for that I will need a joint action. Recall what is a joint action of a group on a real algebra. So first, I define this map, which is just conjugation. This is from G to G. So I take element H, and this is for any G, another element of a group. So this is just conjugation by G. Well, then this is a smooth map. I can take differential of it at identity. I get a map from G to G. We have, so I just denote this as at G. At G. So at G is a notation for DECG, for any G from the group. So for any some да. Okay, so for any G element of a group, I have a map from linear map from Lie algebra to Lie algebra. By the way, this is representation, which is called a joint representation. Not that we again need this, I guess, but this respects, so multiplication in here goes to, you know, composition of linear maps. So in this sense, it's representation. It is smooth. This takes some you know, accuracy to show that, but this is really a representation of a group on a vector space, which is Lie algebra. And so I have the following proposition. If I take my omega that I define here, consider its pullback with respect to alpha G, well, and consider evaluated at some vector V, vector field on P. This is the same as first evaluating omega on V. And then this, all this is going on, say, at some point P, right? So I evaluate this and look at this point at its value at point P, this will give me an element in G. And then on this element, to this element, I apply add G. The same G, which is here. So, like this.
Это альфа, да?
Да, это альфа, которая вот где-то была. Ну, это наше действие. Ну, потому что pullback. Значит, сначала беру форму, и ее pullback относительно. Но это опять та же самая форма. Ну, в смысле, не та же самая, а тоже форма на... это тоже форма, ну, тоже элемент вот такой. Вот. Потому что альфа-G – это дифеморфизм, на самом деле, из P в P. Вот. Ну, вычисляю ее на каком-то векторе V и сажаю в какую-то точку. Ну, я тут, чтобы слишком много не было скобочек, эту точку не написал. Вот. Это то же самое, что я беру омегу, вычисляю ее на V, сажаю в эту точку, и потом применяю присоединенное действие группы. Окей.
Почему это?
Let's prove it. Okay, I erased. So this is this follows from the fact. Now I need to use the my connection is principle, right? Okay, proof. So I take my V, and well, it is decomposed as its horizontal component plus vertical component. Right, and this is actually so H of V is H of V. I leave it like that, but my vertical direction of my tangent space at P is the same as actually Lie algebra, right? So this is actually psi bar for some psi from G. So I take a vector field, right? And at each point I decompose it to horizontal and vertical component, right? And at some point P, well, I need to fix point, okay?
Здесь это разложение, оно относительно чего?
Ну, вот у вас в каждой точке ваш касательное пространство к P – это прямая сумма VP и HP. И вот вы относительно этой прямой суммы раскладываете. Вот. И у вас есть как бы однозначное разложение. Да. Ну, надо и точку поставить, да. Значит, ну, давайте вот так вот напишем. Да, если точку не подставлять, то там могут вылезать, по идее, разные ксай. Вот. Ну, кстати говоря, ну сейчас посмотрим, сработает или нет. То есть если я хочу на самом деле нет, ну хорошо, вот давайте вот так. Значит, хорошо, а теперь давайте now let me try to do this. So I have alpha G star omega of V. Well, this at P, this at P is the same, just by definition of pullback, as omega of P right action by G of dp alpha G of Vp. It's just from definition of pullback. This is the same as omega pg dp alpha G of H of Vp, right?
Понятно. А почему V это G? То есть по V, да, менять местами, только V. Почему? Сейчас это так увидеть, почему, ну, омега?
Да.
V G.
Нет, это просто определение, что такое pullback. Можно да.
Он так определяет сейчас.
Да.
А почему в такой точке?
Ну, он сдвигает как бы в другую точку.
Которая будет в данном случае?
Ну, да. Да, потому что альфа сдвинул эту точку тоже. Да. Ну, и это как раз правое действие, поэтому вот он так. Это просто альфа от G, примененное к P, и все. Вот. Значит, теперь я подставляю сюда бета-разложение. У меня будет вот такое, плюс dp alpha G of psi bar at P. This is the same as, so this I should say leaves, because our connection is principal, now I'm using it, this leaves an H P G of P. So this was an HP of P. The action of d alpha moves it to here, because our connection is principal. Because connection is principal. Now, therefore, it means, so this is actually projection along vertical component. Applied to horizontal component is 0. So this is gone, because this is really projection to vertical component. Now I am only left with this. So I have omega P dot G of dP alpha G of psi bar at P. Okay. So now I need to recall what is differential. And this guy has also corresponds to a tangent vector of some curve. I also need to recall this. So let me move here. So this is equal, so this is equal to omega P dot G of, so I take curve P gamma psi and apply alpha G to it. Right, well, basically, I'm, okay. And then I take prime of it and take 0. So this is just definition of differential. This equals to
У нас ро зета P, оно было, да, как бы, производная применена к P дот гамма.
Да.
А как мы производную вычислить за альфа?
Ну как, вот, нет, сейчас, у меня dp альфа g,
Было к этому вектору.
я применяю к этому вектору.
Вектор это
Этот вектор – это касательный вектор в TP в точке P. Вот, и этот вектор в TP в точке P касательный к какой кривой? Вот к этой. Теперь, чтобы значит, применить дифференциал альфа к ней, я беру эту кривую, вычисляю альфа на этой кривой и беру производную. Okay, so this, so I need to recall what is G. G is just right action, right? So actually this P times gamma multiplied by G, right? So it's omega of P dot G of P gamma psi G prime at 0. And this right action, so therefore it's just product of these two. Okay, now here comes the conjugation, because I have P dot G here and only P here. So I want to make it P dot G here and earning G inverse here. So I get omega P dot G of P dot G applied and then dot G inverse gamma psi G. This right, and then I need to take prime at 0. Произошло, что я сюда всобачил g в минус первый g.
Куда?
Ну вот, значит, это правое действие. Значит, я могу вот на это подействовать справа на g в минус первый. Ну, а это действие. Вот, поэтому я, ну, могу подействовать g на g в минус первый. Это действие, поэтому g в минус первый перескочит сюда. Ну, это то же самое, да, но вот я как бы сюда вставил g на g в минус первый, потому что здесь я хочу сопряжение использовать, потому что у меня вот это. Значит, окей. So this is actually omega P dot G of, so I take at G applied to this, well, at G applied to psi, and then take bar at point P dot G. So this equals to this, I claim. Right? So what do I do? At G is differential of this map. So basically I take so this is the same as add, so this curve, so tangent vector to this curve is the same as add G to tangent vector of gamma psi. So therefore tangent vector to this curve is add G psi. Then I apply it to the point P dot G, right, and take corresponding tangent vector. This is just by definition is taking the tangent vector to this curve, well, which is in the algebra, and put bar over it. And well, this means that it is at point P dot G. Okay. Right. So this is the same as just add G, doesn't depend on point now, because it's just after identification of the fiber with Lie, tangent space to fiber with Lie algebra. This is the same as add G psi. Because we wrote this, remember, omega of psi bar is psi. So I'm applying it here. Now what? I need to, I started here, arrived here, so I need to continue and get somehow this guy. Right? So let me, what it's better to, okay, let me erase this. So I claim, well, I'm using heavily that this doesn't depend really on a point. And so psi is now at G. So psi is, so it's at G applied to omega of psi bar, right? Well, at point P. Doesn't really matter at which point I'll take. Right. And then this equals to add G of omega P, and then I'm using again this trick to insert back this horizontal component that I lost in the beginning. I'm inserting it back, and I get omega P of H of V P plus psi bar P. Right? And this is at G of omega P of V P. So we are done. I always love when period of like the length of writing a proof on the board is exactly the period of the cycle when we're raising new stuff and old stuff and writing new. Right, so we exactly came to the formulation of proposition. Anyways, so this gives us, okay, so we can now go the other way, right? So we would like to say that we have equivalent definition of two equivalent definitions of principal bundle. The first one and the one which says that okay, this one form which satisfies this, and omega of psi bar is psi. So we prove that it is equivalent in one direction. So let's go to the other direction. So proposition. Suppose that omega, well, this is section in here, sorry, T star P tensor gamma of P times G satisfies psi omega of psi bar is psi, and this relation that I will denote by star. Then I can define now horizontal subbundle by the following. It is kernel of omega. So then this defines a principle, G connection. So okay, is it clear what is kernel of omega? So basically, we just at every point P, we look at vectors in vectors in tangent space to P, which if I plug into omega, I get 0. And this gives us action. This gives us subbundle, which is horizontal. The fact that it is horizontal so it should give me, yes, the fact that it is horizontal is just because it kills everything that is not in omega, psi bar is psi. Well, okay, let's see. So just let's try to prove. So first, what I need to check is that if I take V, some vector Vp from tangent space to P, right? Well, it's from the kernel, so V omega P of Vp is 0. So take then I would like to see if I need to apply d alpha g to it and see if this is inside kernel as well. Right? Well, this will mean that the corresponding condition on HP that it is invariant with respect to the action of alpha. Okay, then, well, how to check this? This should be easy. Omega, we need to apply omega of P dot G of D P alpha of G applied to Vp. This is the same as, of course, just pullback of omega evaluated at Vp, but this is the same as at G of omega P of Vp, but this guy is 0, so it is 0. So it satisfies invariance property with respect to alpha G. Now let us think if it is so horizontal, right? It should, at each point, it should be a complement to vertical. Is it obvious or not? It should be obvious. Right. So my HP, I would like my TP to be HP plus VP. Right. So kernel of pi, right, of course is not, the kernel of pi is not, does not intersect kernel of omega. This is because this condition. And psi is exactly like G is exactly the kernel of pi, right? Because pi takes anything in vertical, which is just Lie algebra, the same as Lie algebra, and take it to 0. So this guy does not take it to 0. Right. So therefore, but why does it give everything the direct sum kernel of pi plus kernel of omega? Not clear, by the way. So suppose kernel is of course, so I might have something outside of G, right, outside of Lie algebra, such that, so what I want to see is that there's no vector going like this, right, which is not in my vertical direction, such that, no, that's not what I want.
А метод по определению вес P хрен G, образ лежит в нем и все порождает, потому что на таких вот он и возникает.
Ну да.
Поэтому у нас образ омега это в точности ядро И, но значит ядро плюс образ.
Сейчас, у нас он идет сюда, все порождает здесь. Да. Ну да, как бы, грубо говоря, у нас же, okay, we have a trivial bundle, right? And so therefore everything which, yeah, so trivial bundle, and so therefore it's it's kind of identity tensor. So omega, right, gives me right. It is kind of identity tensor omega here, right? So differential of omega, I mean, right? And so therefore it is everything which is 0 is exactly no, I don't know. Anyways, should be true. I'm kind of a little bit. I thought it is obvious, so I didn't write anything. So okay, but it should be true. Anyways, so let me not waste your time, since I cannot spell it out properly. we can, try to discuss it after if you wish, or you can do it by yourself, but okay, this should be true. Okay, so I would rather proceed and do, okay, and so let me give the following definition, which is equivalent up to some things, some these technical moments. Principal connection on P, so this is principal G bundle, is one form, is a choice, well, is a one form omega from gamma of T star P tensor P times G, satisfying two conditions. First, omega of psi bar is psi, and second, this star condition. Okay, let me rewrite one more time. Right, so I'll pull back with respect to alpha G of V is the same as you first relate at V and then take adjoint. This is, in many cases, this is much more handy because you can just make new connections out of old ones and check just these two conditions. And this is usually kind of obvious, so you just need to check this. Okay, so this is another description of principal connection. Okay, so it's a good place to have a break for 10 minutes. And then after break, we'll talk about characteristic classes then. Ну да. Ну правильно, правильно. Это просто потому, что это омега — это проектор. То есть это как бы, ну да.